All right, 2.6b, related rates. Here we go.
A 5-foot ladder leaning against a wall slips so that the base moves away from the wall at a rate of 2 feet per second. How fast will the top of the ladder be moving down the wall when the base is 4 feet from the wall?
All right, fantastic. So we're going to draw our picture. All right. And so I'm going to refer to these as X and Y and Z. And we're going to talk about what that is. And so what did they give me? It said it's a 5-foot ladder. And so which one did that give me? My Z is 5. And then it says it's leaning against the wall, so that the base of the base moves away from at a rate of 2 feet per second. So what did that give me? It's a rate. And so now what is that? That's not X, but what? Dx dt. It is the rate at which X is moving. And is it positive or negative 2? It's positive because X is getting larger. It's moving away from the wall. And then it says, how fast will the top of the ladder be moving down the wall? So what did we try to solve for? We're solving for a rate of y, so we're solving for what? dy dt. And so then it says when the base is 4 feet. So what did that give us? My x is equal to what? 4. All right. And so what kind of triangle did it make? A right triangle. So what are we going to be using? Pythagorean. So we have x squared plus y squared is equal to z squared. Now, eventually we need to get to dy dt. So what am I going to take a derivative with respect to? T. Time. All right. And so now let's take a derivative of x squared. So then we get what? 2x dx dt. And then plus the derivative of y squared, which is 2y dy dt. And then is equal to what? 2z dz dt. And then we can cross out all of our 2's. And so now we're going to substitute in everything that we know. Do I know my x? Yes. So what is x equal to? 4. And then do we know dx dt? Yes. So that is what? 2. Do we know a y? Not right now, but we can solve for it really quickly. What is it? It's 3. Okay, because we know it's a Pythag triple, actually written by the Babylonians long before Pythag even was alive. All right, and so then we're solving for dy dt. So that's what dy dt is right there. Is equal to, do I have a z? 5. Do I have a dz dt? It's something. What is it?
0.
It's 0. Tell me why it's 0.
Because you said it last time. I don't know.
So here we go. So let's do it. And so now we solve for dy dt. So what is dy dt?
-8/3.
-8/3. All right.
A boat passes a fixed buoy at 9 a.m. heading due west at 3 miles per hour. Another boat passes the same buoy at 10 a.m. heading due north at 5 miles per hour. How fast is the distance between the boats changing at noon?
All right. Whew, that was a lot. So it passes a fixed buoy at 9 a.m. heading due west at 3 miles per hour. And then we need to figure out what's happening at noon. And so my boat is this way. All right. It's not a sailboat, but I'm just going to put a flag on it just for funsies. And so I'm going to represent that as my x. And so what is my x then? It's my distance. What is my distance? It passes at 9 a.m. and then at noon. So what's the distance of my boat from my buoy?
3 miles per hour, so it'd be 9.
9. So x is equal to 9. And what's dx dt? What is the rate at which my boat is traveling? 3. So dx dt is 3. And then the next boat passes the same buoy at 10 a.m. and goes north at 5 miles per hour. So here's my next boat. It doesn't have a flag on it, but I'm going to put a flag. All right, and so then what would be my y? What would be my y on this one? It goes from 10 a.m. to noon. 10. And what is my dy dt? 5, because that's how fast it's going. That's the rate at which it's traveling. And so then what's the question being asked? How fast is the distance between the boats changing? So I'm trying to figure out what that part is changing. I'm going to call that z, but what am I actually solving for? The rate at which it's traveling. So what am I actually solving for? dz dt. All right, so what did we use? We made a what again? A right triangle. So guess what we're going to use? We're going to use Pythag. So now I have x squared plus y squared is equal to z squared. Bless you. And so now I need to take a derivative. So what's my derivative? 2x dx dt plus 2y dy dt is equal to 2z dz dt. All right, and so we're going to cancel out all our 2's, and we're going to substitute in everything that we know. So do I know my x? Yes. What is it? 9. Do I know dx dt?
Yes.
3. Plus my y of 10. Do I know my dy dt? 5. And then is equal to, do I know my z?
Yes.
Not yet, but we can solve for it very quickly. So it's a right triangle. So then we get 9 squared, which is how much?
81.
81. 10 squared, which is? So then I add them together, so I get what? 181. And then I want to do what to it? Square root it. So now I have the square root of 181 dz dt. All right, and then how do I solve for dz dt? I just divide by square root of 181. All right, and so let's do a little bit of math. 9 times 3 is? 5 times 10 is? We add them together, we get 77 over the square root of 181. And that is how fast the distance of my boats are changing.
So we don't have to.
So we're looking for a 6-foot tall person. We got Caroline. Go for it.
Suppose a 6-foot tall person, Caroline, is 12 feet away from an 18-foot lamppost.
All right, let's draw a picture. Let's draw our picture. All right, so we got a lamppost. Looks like Mr. Incredible to me. And so we got 18-foot lamppost, and then we got Caroline at 6 foot tall. All right. All right, and then that 6 foot tall person is 12 foot away. All right, keep going.
If a person is moving away from the lamppost at a rate of 2 feet per second, at what rate is the length of the shadow changing? At what rate is the tip of the shadow changing?
All right, we're not going to actually do that second part. Some years I do it, some years I don't, but I've never seen it on an AP exam, so I'm not doing it this year. All right. We got to just do baby steps in this year. All right, so here we go. All right, so I'm going to help you out on giving the variables. I'm going to call this x and this s. The x for my horizontal distance, this s for my shadow. All right. Has anybody ever walked towards a lamp or walked towards like a street light? What happens to your shadow? The shadow gets smaller. If you walk away from the street light, guess what it does? The shadow gets bigger. Okay, and so we could actually do this in real life, and so this is kind of fun. So it said the person is moving away from the lamppost at 2 feet per second. So what did that say?
That's our dx.
That's our dx dt. Very good. And I'm moving away from my lamppost, so dx dt is what? A positive 2. Very good, Yumio. All right, and so if it were going towards my lamppost, then it would be what? Negative, because then my x is getting what? Smaller. Very good. And so what are we solving for?
ds dt.
ds dt. That's what we're solving for. We're trying to figure out how fast the shadow is changing. All right, and so we're going to go back to geometry a little bit. And so do you see how we have proportional triangles that are made? Like I got this big triangle, and then I got this little triangle. Everybody see that? And so now we're going to make our proportion. And so we're going to make our proportion by saying it's a shadow over 6 foot Caroline. And then we have our shadow plus our x distance over this 18-foot lamppost.
Right.
How do we solve proportions now? We do what? We cross multiply. And so now I'd end up with 18s is equal to 6s plus 6x. All right. I personally like to get all my s's and x's together. And so how many s's do I end up having this one? 12 s's is equal to 6x. And this is where I like to start taking derivatives. And so now when we take a derivative, what's the derivative of 12s with respect to time? 12 ds dt. And then is equal to 6 dx dt. So now we're just going to substitute in everything we know. So do I know my ds dt? No. Do I know dx dt? Yes. So now I have 6 times 2. And so then I'm going to divide it by what? 12. And so then I divide that by 12, and I end up getting ds dt is equal to 1 foot per second. All right.
We all love you.
Cohen. Go for it.
Suppose that a liquid is to be cleared of a sediment by pouring it through a cone-shaped filter, assuming that the height of the cone is 16 inches and the radius at the base of the cone is 4 inches. If the liquid is flowing out of the cone at a rate of 2 inches cubed per minute when the level is 8 inches deep, how fast is the depth of the liquid decreasing at that instant?
Woo, that was a lot. Let's break it down. All right, so we have a cone. All right, we have a cone, and the height of the cone is 16 inches. So we got our height of our cone is 16. And then it says the radius is what? 4 inches. Now, sometimes they'll say like how far it is across the circle of the cone. All right, and so if like they say it's 8 inches across, then you know the what? The radius is 4. Okay, you're always going to be dealing with the radius and not the diameter on these, so don't get tricked on that. All right, and then it says the water is flowing out of the cone at a rate of 2. So what does that tell us?
No, RDT. I don't know. It's
Okay, it's a volume of a cone. So dV dt is what?
2.
Not 2, but negative 2. Why is it negative right now? Because it's going out. All right? So if something were going into my cone, then it would be what? A positive 2. Okay? All right, and then it says the level is 8 inches deep. And so that tells me my height is 8. And then it says how fast is the depth of the water, or depth of the liquid decreasing. And so what we're trying to solve for is dH dt. And so that's how we broke that one down. So now we need the volume of our cone. And I'm going to give this to you. AP will as well. What is the volume of the cone? Does anybody remember? 1/3 base, which is what? It's a circle, so it's pi r squared. And then times the height. Very good. So,
You know that by heart, right?
all right. So our volume equation. What is our volume equation in terms of right now? How many variables? 2. Okay? It's in terms of 2 variables. And so I have R and H. So if I were to take a derivative right now, I have to use product rule. Is everybody following me? And then I'm going to get a dr dt and a dH dt popping out. However, all I want to solve for is what? dH dt. So this is where we actually need to use our proportions that they gave me. All right? Because all I want this in terms of is one variable. And in this case, what term do I want it in? An H. All right? And so I'm going to make my proportion. So I have a proportion of R over H, which would be equal to what in this case? What's my R? 4 over what? 16. And so I personally would like to simplify it because I'm going to start using it. So what does that simplify to? 1 over 4. And so I want to replace my variable of R with something in terms of H. So what does R equal? 1/4 H. I'm good with that. All right. Sometimes I call it H over 4, but it's the samesies. So now we're going to take this and we're going to plug it in right there. All right. We're going to substitute it in. It felt disgusting, didn't it? All right. And so we're going to substitute that in right there. And so now when I substitute in this, I'm now all in terms of H. So now I have volume is equal to 1/3 pi. And then I have, can I call it H over 4?
Yeah.
I'm going for it. And then squared and then times H. All right. And so now I need to square this quantity. But right now I still have it all in terms of H. And that's a good thing. But I'm going to simplify it before I get going. And so H squared is? H squared. 4 squared is 16. And so that H squared is going to mess with that H to become H cubed over 16. And so there's my volume equation. And so now I'm ready to take a derivative because now I'm in terms of one variable of H in this case. All right? And so now when we take a derivative, what happens to this 3? it's getting multiplied with this 1/3, and guess what? It goes, and so then we now have pi, and then h what? Squared over 16, but then what pops out? dH dt. So now all we do is just substitute in everything we know. So what's my dv dt?
-2.
-2 is equal to pi. And what is my h? 8. So now I have 8 squared over 16. And then do I know my dH dt? Nope, that's what we're solving for. And so what is 8 squared? 64. 64 divided by 16 is how much? 4. So now I have -2 is equal to 4 pi dH dt. And so then what do we need to do? Divide by 4 pi. So now we have -2 over 4 pi, which can simplify to -1 over 2 pi. Here's your related rates worksheet. All right.